Hello, this is the 2015 practice exam from the College Board. Number one requires nothing but the quotient rule. Just be careful with the negative signs. So we have y prime equals the denominator, which is x squared plus 1, times the derivative of the numerator, which is 2x, minus the numerator, times the derivative of the denominator, which is 2x, over x squared plus 1 squared. Well, easily enough, we're substituting x equal to 1 in there. So let's see what we get. So we have 1 plus 1, that's 2. 2 times 1, that's 2. 1 minus 2, it's negative 1. And 2 times 1, which is 2. 1 plus 1, that's 2 squared. So let's see, let's make sure we're not making any errors here. 4 plus 2, that's 6 over 4. 3 halves, choice E. Nothing really tricky about that at all, really. Okay, pretty straightforward. That's what you'd expect for the first question. Okay, let's see what the next question brings. Number 2. I'm going to do these in groups of 7. Okay. Implicit differentiation, your best friend, yay. Okay, so we have, let's make sure I'm getting in focus here. Let's focus on my hand. Okay. So 2y prime minus, okay, and this is where you have to pay attention, okay? So think of negative 2x squared as one factor and y as the other factor. So then it would be the first factor times the derivative of the second plus the second one times the derivative of the first. So, but the derivative of the first is negative 4x. So it's going to be minus 4xy equals 0. Common mistake is to leave this an 8 over here. Okay, so we're looking for dy dx, so just isolate y prime. So add 4xy to both sides. We'll divide everything by 2 first. So we're going to add this to, dividing everything by 2, we have y prime minus x squared y prime minus 2xy equals 0. Okay. Moving this over, adding 2xy and then factoring y prime from here. Get that. Divide both sides by this factor. And there you go. 2xy over y minus x squared. I don't know, it looks like choice B. Again, straightforward, no tricks. Nothing special, you just need to pay attention to that negative there. So, some of you factor it out and just find a product rule here and then distribute the negative, whatever is easier for you. But you've got to take that into account. Too many of you made that mistake on the quizzes that we've had on the homeworks. Okay, let's turn to number 3. What do we have here? Oh, integration. Looks like use substitution. Excuse me. Some of you might be able to do this backwards. This is almost, this here is almost the derivative of x to the 3rd plus 5 to the 7th. See, the derivative of that would be 7x cubed plus 5 to the 6th, right? And that would be the derivative, times the derivative of the inside, which is 3x squared, right? But our derivative here has only x squared, doesn't have the 7 times the 3 here. So this 7 times 3, if we had a 21 in here, that would be nice. Well, let's put it in. Yeah, remember we could do that. Could put a 21 in here. Just put a little teeny weeny baby 21. You gotta compensate for that by putting a 1 over 21 on the outside. Okay. So at least this is one way of doing it. That's how I would do it. So it's choice E. But if you're not fond of this method, just use u substitution. So u is x cubed plus 5. du is 3x squared dx. So a third du equals x squared dx. And then sub in. So x squared dx becomes a third du. And x cubed plus 5 to the 6th becomes u to the 6th. And then you get 1 over 3 times u to the 7 over 7 plus c. Right, and you see where this is going. Right, it's u to the 7 over 21 plus c, where u is x cubed plus 5 to the 7 over 21 plus c. Still choice C. Moving on. Okay, number 4. Ooh. Continuous function. Left Riemann. Okay, so we're doing LRAM, right? Okay, on those 3 intervals. So LRAM means you're starting from the left. So we're using the first f value here, which is 4. That would be our height. Our first interval is from 0 to 25. So since we're using rectangles, the base of the first rectangle is 25. Then the next one is 5, and the next one is 20, right? So the first height is 4, and the first interval is 25. The next height is 6, and the interval corresponding to it is 5. And then we have 8 times the last interval, which is 20. And if you add all of those up, we should get 290. Yeah, this is 100, that's 160, that's 30, there we go. That's choice A. Okay, so remember in LRAM, you start from the left and you don't use the last y value. If for RRAM, you start from the right and you don't use the left value for y. Number 5, more integrals. Okay. The length of the curve. So length of the curve means that you have to know the formula for the length of the curve. Okay, so the formula for Cartesian is the length of the curve from A to B, square root of 1 plus f prime of x squared. That's the formula. Okay. So f of x is square root of x here. So the f prime is 1 over 2 square root of x. And when I square it, I get 1 over 4x. Right? Y prime equals 1 over 2 square root of x. So I'm squaring that and I'm getting this. Yeah? I didn't lose anybody, I hope. Okay. So it can't be this because it says negative in it. That makes no sense. Okay. From... excuse me, from 1 to 4. That's the interval here. So I don't think we need to do anything else. And that's it. There you go. Choice D. Okay, we're cruising. Tomorrow for this video. Number 6. Ooh. See, first when I looked at that question, I thought I had to complete the square, but that ended up not helping. And eventually you get an inverse trig function. But if you look at the choices, they all have ln, so that made me think I have to do integration by partial fractions. So if we factor the denominator, what is this? X plus 8, x plus 2, I guess. Yes. Okay. And separate this into 2 integrals. Sorry, this keeps getting out of focus. X plus 2. This is a plus. I don't know if it's going to be a plus. We have to see. All right. So let's remember how we get the A and the B. Okay. So the root of this is negative 8. So negative 8, we cover this up and we plug in negative 8 into the remainder. So negative 8 plus 2, that's negative 6. 6 divided by negative 6 is negative 1. So that's what goes up here. Then you do the same thing for this one. The root of this is negative 2. So you cover this up and you put negative 2 in the leftovers. So 6 over 6, that would be 1. So this is 1. Okay, I'm going to look at this switched. So I'm going to take the antiderivative of this first, which is ln of x plus 2. And then I'm going to subtract the antiderivative of that, which is ln of x plus 8. And can you think of why I did this? Plus c. Because I know that there is a formula for ln of a minus ln of b, and that is ln of a over b, right? X plus 2 over x plus 8 plus c. Is there any of the choices? Do any of the choices match that? X plus 8. Oh. Yeah, B does. That's it. Choice B. I don't know why I got confused there for a second. All right, number 7. Oh, seriously, can it get any more simple? All right, so the derivative of a composition, use the chain rule. So f prime of g of x times g prime of x. This is the derivative of f of g of x. Okay, that's just by definition. If you look at this, though, the function here, the f prime, we're going to need to use it. So let's find it now. It's 2x. So f prime of x is 2x, so f prime of g is 2g. And this is just g prime of x. We don't know what that is. So 2g of x, g prime of x looks like choice D. Done. Okay, 11 minutes, not bad.